Hey everybody, I see we've got about 15 of you on the line right now. I'm going to wait until right at 11 to get started, but I am here. We're getting ready to rock and roll. It's going to be radio silence here for a few minutes while we wait for more people to trickle in, and then I'll get started a little after 11. Thank you all very much for attending. Appreciate the promptness, and hopefully we can have a little bit of fun learning about frequencies this morning. Thanks, guys. Hey, since the last time I spoke a few minutes ago, I see we've got about another 10 or 12 people that have jumped on. So just letting everybody know we will get started right at 11. The purpose of the presentation this morning is to go through RF frequencies. I'll cover in detail kind of what that path is going to be. We'll obviously tie in Z-band a little bit and how we utilize it, and what it means to our equipment as we're going through. But for the most part, it's just going to be general information on the industry writ large. I will chime back in here in a minute or two. I'll let people have another minute to trickle in, and then we'll get started here about probably 11:01, 11:02. Be right back. All right. Good morning, everybody. Time to get started and get rocking and rolling. For those of you who haven't done this before, the GoToMeeting panel will give you the ability to ask questions. So you are all on mute at this particular point in time. If you have any questions, please chat them into me. I do keep the questions box popped out throughout the course of the presentation. I kind of tend to hold them all to the end if necessary. But if I've missed something obvious in the middle and you chatted into me that I've missed the obvious thing, I do see the questions as they are coming in. So I want to get started this morning we were having this conversation in the office last week or 2 weeks ago, and it was just about frequencies in general and so many of the issues that we have with our customers and when we're troubleshooting systems is a basic misunderstanding of what is actually going on within a video system, within a TV system in the modern age. So wanted to cover some of the questions that we get, how that it's changed over the last decade, and really kind of go through and talk about RF in the digital world, and obviously with the focus on the Z-band side of things or the focus on the CATV side of things. So first thing to really kind of note is that RF frequencies are everywhere in our modern world. Anything down to small frequencies being sent out at 1 hertz to satellite communications frequencies. I actually have an uncle who works, he's doing some work for NASA at this point in time on chips and high frequency isolators up in the 50 gigahertz range, I think, is some of the isolators that he's working on now. So the range in which we are sending RF communications is everywhere at this point in time. If you're one of the conspiracy theorists that believes we're all going to end up with cancer in our 60s and 70s because of the amount of RF that's floating around in the world, this is not a chart that's going to help you feel any better about it. So when we're talking about RF frequencies, this is actually one of the first questions that I always end up getting asked is, what the heck are you talking about when you say it's an RF broadcast? RF is radio frequency communication. So everyone, the comparison that everyone seems to get is you're driving in your car and you turn on your FM radio and you tune into 89.1, 89.7, 95.1, whatever your favorite channel is. You are actually tuning into a radio frequency coming in from a tower and picking up the information that is on that radio frequency. And you obviously have the selection of everything that's broadcasting, every tower that's broadcasting within your range. All of the communications that we get, mobile devices, OTT, over-the-air, local TV stations, all of those are using that same basic backbone in communications technology. So if you have an antenna on your roof and you're pulling 30 local channels in the suburbs of Des Moines, Iowa, those are radio frequency RF communications. If you are talking on your cell phone or pulling 5G data on your cell phone while you're out and about, those are radio frequency communications with from your phone to the cell tower, from the cell tower to whatever the cell tower happens to be chatting with. This is all RF. All that data is being sent back and forth as RF. So when we're out and giving these presentations and we're talking about what is RF, I mean, RF is really everything. RF is every technology that we use for communications when we are out and about in our daily lives. The portion of this that we tend to focus on as Z-band is the RF frequencies that are set aside for cable TV and TV transmission in general. And I'll come back to this later in the presentation, but it is important to note that this has changed dramatically over the last few years. We have gone from not necessarily the frequencies themselves changing, but gone from analog transmission to digital transmission, and we are constantly chunking off more and more of this RF space for cellular communication. We're using more and more cell data on a day-to-day, week-to-week basis than what we had been previously. So this frequency space, while it remains the same, is constantly being reallocated. There's actually another bandwidth auction that will take place here. I think they're set for like November or December of this year. We were just reading about it in the office last week, which is going to change this frequency space again. But the way that the FCC has this set up is that within your the lower range of the RF frequency spectrum, basically from 54 to 860 megahertz, you have set aside for radio broadcast. There's area set aside for ham radio operators. There's area set aside for TV channels. And we're going to focus in on the TV channels and start with what we probably all, most of us on this broadcast will remember, which is the original video distribution of analog video signals. So this was, as I was growing up, tube TV with a little knob on the front. You walk up, you turn the knob, it goes to channel 4. Channel 4 is NBC. You turn the knob, channel 5 is Fox. And then you had like maybe channel 7 is ABC and channel 9 is CBS, and that was it. That was all there. There were no more channels in my household growing up, at least not until, I don't know, maybe the mid-90s. We got a little bit more than that where I was at. So what this actually was this is channel 3 is a 6 megahertz wide RF frequency that had embedded upon it all of the analog and audio and video data required in that analog frequency for the TV to pick up the television signal. And this is where we've been. This is what most of us are familiar with. This is what the majority of us in the industry, this is where we got our start, is that we had these 6 megahertz wide frequencies that carried on them a single program, and that was what it was. The cool part about analog, video quality wasn't great, right? Most of the time we're talking about 720 by 480 is our maximum resolution, and it's a 4 by 3 aspect ratio, so you have the kind of squared out TV looking squared out image on your television, but it was robust. If it got a little bit of interference, you would get some waves in the video, or you would kind of get a little bit of fuzz fighting back and forth. If you had the system completely over amplified, you could get analog audio bleeding over onto an adjacent channel rather than staying on the channel that it was on. I mean, a lot of us are very familiar with some of the issues that we had with analog video systems. And the reason for this is the analog video actually presented itself, as you can see on the screen here, as a sine wave to the TV signal. So now obviously what we have here is a perfect sine wave. And you can't see, I'll try and bring my mouse over. On the lower third of this sine wave is where the analog or the audio video carrier would present itself in an analog video system. And then on the upper portion of this curve is where the video portion of the signal would present itself in the analog wave. So if you had this wave and you amplified it, over exaggerated, come way over the top here, this audio carrier that resided on this portion of the wave would actually get pushed up and out into the adjacent video channel, which is why at certain times or in certain systems, you would be going through your TV channels and would hear the audio from ABC on CBS, or you would hear the audio from NBC on the ABC station. This was nothing more than an overamplification or a distortion of the analog sine wave that caused it to bleed over into the adjacent video channel. And this was video transmission for, the majority of the time that video has been around, from the advent of these TV systems up until really the 90s to early 2000s. I mean, if you look it up and you begin to read about it, the actual digital video transformation that happened in the U.S. didn't officially kick off until about 2008 when we started to require it and had to go through the whole thing of the converter boxes and everything else that we went through there in the early and mid 2000s. And actually, there are still stations out there, and there are still some low-power broadcasters that are broadcasting in analog. We haven't totally completed that digital, that analog sunset at this point in time. There are exemptions that are handed out and extended still every year. So this is still a thing. I mean, and as Z-Band, speaking to us specifically, we still have, I wouldn't say it's a majority at this point in time, but a significant number of our customers are utilizing analog video for their internal distribution systems today. So this is still something that is relevant within the industry. So I wanted to kind of start with the background of analog, what it is, what that has meant for us, and kind of introduce some of the terminology that comes along with that. So that analog form, that sine wave, resides in this 6 megahertz frequency. As we've transitioned into digital, digital also resides in that 6 megahertz frequency. Within one of these 6 megahertz frequencies in our RF video spectrum, we can distribute about 38.8 megabits per second worth of data. And this is about what that looks like on a 6 megahertz QAM output channel. So you can see here that now we've got, rather than like you saw on the previous slide, rather than that sine wave, I'm going to go back just so we can take a look at it, we've now got square wave with the top, bottom, top, bottom. So what we get here when we get distortion, whereas in the analog we got this massive kind of bump, or you get shaking the lines here, when you get distortion here, you lower the top, or you maybe get not a level top across the top of the digital feed, and that is something that we'll touch on here in just a second as to what that means when you start to see distortion in digital video. But it's a more robust wave, and it also can carry significantly more data than what we were talking about when we were talking about the analog video wave. And you also have the way that 6 megahertz frequency spectrum is broken up here, with where the audio, the luminescence, the video, all of that is built in, where you're not pushing out and bleeding over into adjacent channels. It's almost non-existent that you have bleed over from one channel to the next in a digital video system, just due to the nature of that square wave and the way things are made up within the digital video system. So as we've made this transition from analog into digital, we are using the exact same 6 megahertz frequencies as we were with analog. We're just using them differently. So we're going to take a slide right now and just look at these 6 megahertz frequencies. And this is a published chart. I highly recommend that you talk to your local cable TV distributor if you have to deal with this, and jump into getting a broadband reference guide. So this is a standard table, a standard set of information across the U.S. and North America. And what it tells me is that if I am on channel 7 if I've got my antenna on the roof and bringing it down into my TV because I'm cord cutter and I don't have anything from the local cable company, or maybe I just want a backup in case of emergency situations or cable company power outage. I've got that antenna. It's plugged into my television directly. If I am on channel number 7, I'm going to use my mouse here so you guys can see again, channel number 7. That is a frequency of 177 megahertz, which is actually going to represent itself in devices like an ATX UCrypt, or a device like a COM 3000, a Dish Smart Box, any kind of QAM to IP transcoder, whether it be from Blonder Tongue, Viveo, whoever that would happen to be. That's actually going to represent itself as 177,000. You always need to add the 3 zeros on the end there to get to the actual representation that most of the QAM to IP and ATSC to IP devices that we work with want to see. This is a fixed chart, right? So I look at this channel 7, and it's actually always representing here 177 is the center frequency. So that frequency actually rides from 174 megahertz to 180 megahertz, and that is the 6 megahertz range that channel 7 takes up. And then within channel 7, this is different than what things have been in the analog system. I mean, back when I was growing up, channel 7 was ABC, and that was the only thing that was on that channel, is you could watch ABC if you were watching channel 7. In the modern age, and I'm using 5 in the PowerPoint slide, I'm going to keep talking channel 7 because that's what I was chatting about when comparing to analog. In the digital age, that 6 megahertz wide channel 7, is now an MPTS. It's a multi-program transport stream. So channel 7 doesn't just encompass ABC anymore. It has ABC's high definition programming on 7.1, and then on 7.2 it'll maybe have a game show channel. 7.3 it'll have the Heroes Network. 7.4 will be some sort of local access or public broadcasting. So each one of these 6 megahertz channels is now an MPTS. And I have a lot of problem with this when I'm speaking to folks out in the industry or when we're talking to people in the office, where I will use these terminologies interchangeably. What channel are you watching? Oh, well, I'm watching ABC. And that may not necessarily be accurate for the system that you're working in. The program that I'm watching, the individual program 7.1, is ABC, and that's what I'm watching. But the channel 7, encompasses multiple programs. And this is a kind of a language and terminology issue where some folks who are a little more familiar with this on the digital side of things or have worked with this longer don't use these terms interchangeably, where some of us who have only a TV background, and specifically an analog TV background, will confuse the terminologies of channel and program. But it is important to note that the channel is always referring to the 6 megahertz wide RF frequency, and then the programs are the individual transmissions that are sent within that frequency. So that is, it's important to note. The other thing that's important to note now in digital video is distortion is different. There are basically 3 states of digital video. I mean, analog video has infinite states. It could look great. It could be a little fuzzy. You could get audio bleeding over. It could be a little more fuzzy. It could be a little less fuzzy. There could be, kind of waves running through the images. Analog video had infinite states of still actually being video. Digital video has essentially 3 states. It looks perfect. There is pixelization, and it's gone completely. Now, the level of pixelization can change a little bit. The dropped packets can represent themselves as color bars or green spots on the screen. But essentially, with digital, because of that square wave, it's far more robust in the amount of error that you can have, or the amount of distortion that you can have in the stream before you start to see things breaking loose and you're starting to lose your video quality. So that is the other thing that has been great about this move towards digital, is we are far more robust with what we can do while we keep crystal clear picture. Now, as soon as you hit that threshold where you no longer have crystal clear picture, things fall off of a cliff very, very quickly. But it is important to note that that is one of the things with digital that is nice. One of the things that has complicated our digital video transmission, and this, to be really clear, I've put it in bold on the slide, and I want to make sure that I focus in on it here while we're talking about it. This is one of our biggest pain points as Z-Band when talking with commercial customers. And so commercial customers, healthcare institutions, banking institutions. So anybody that has got a internal TV video system where they are building a head end or taking a feed off the street, remodulating those channels, and then creating their own internal channel lineup, is a lot of the folks that are watching TV in their office. We are all very familiar with the model of channel 3 is a certain individual channel and only that channel. Channel 4 is a certain individual channel and only that channel. And we just inherently due to how we've seen things over the years, don't like flipping through 5.1, 5.2, 5.3, 6.1, 6.2, 6.3. So the fix for this is what is in the industry virtual channel numbers, where I can take the program that is on that frequency 5.1 and the program that is on that frequency 5.2, and essentially within the digital video data that is being sent, tell the television, okay, I know you see this as frequency 5.1, but I want you to display it as channel 7. And I know you see this next channel as frequency 5.2, but I want you to display it as channel 12, so that the customer, when they're going through and flipping channels, can see, okay, this is channel 3, this is channel 4, this is channel 5, and they get what's called whole part. They get one whole number rather than a two-part, 5.1, 5.2 number as they're flipping through. So as customers, we all like to see these whole part numbers. And myself, working in the industry, I'm this way. I prefer to see channel 45, channel 46, channel 47 as I'm flipping through TV in the hotel. The problem with this is this does not necessarily, these VCNs don't have to correspond with the actual frequency. So to pull this back to a very specific Z-band example, we have a software system with the newest generation of our product, the distribution ZHC, where we can look into each of the ZHCs and we can take a scan of the RF frequency. You can also drop that scan down to individual channels, so one individual 6 megahertz wide channel, and just scan that channel with the software within the ZHC system. We were working with a customer in North Carolina earlier this year that was telling us, we're not seeing, or the video looks terrible on channel 34, right? And so we have one of our engineers go in, work with them, get into the software. We were on a scan on channel 34. There's absolutely nothing. There's no content, no programming whatsoever on channel 34, which obviously isn't correct as far as the customer is concerned, because he has channel 34 on other floors throughout the hospital. So he knows that content is there. He knows he's got a channel 34. It took us a little while to figure it out, but what it actually is a mismatch between what the VCN, the virtual channel number 34, is representing itself as, and where that content was actually being carried. Even though the content was representing itself as channel 34 on the television, what was actually happening was that it was being transmitted somewhere in RF carrier or in the EIA table, channel 50. So the 6 megahertz frequency that was being used for transmission did not in any way align with the VCN that was being put on the TV screen. And this is important to note because these days, almost any commercial TV system is capable of doing this, right? If you have a QAM to IP device or an ATSC to QAM transcoder or one of the bulk conversion devices from the satellite providers, each and every one of these devices is capable of taking those incoming frequencies and remapping them to new outbound frequencies, and also assigning that VCN or that virtual channel number to each individual program. So this is a thing, as you're building headends, it's important to note not only what frequencies that you're using, but also what that VCN to actual EIA table frequency map is. Because if you don't have that information, you could be spending hours of your time troubleshooting the wrong problem, right? You think you have an issue on channel 7 when it's actually a completely different frequency that is causing the issue. So this was never a thing in analog. You couldn't embed virtual channel numbers in an analog video system. Didn't exist, wasn't possible. It is something that has only happened here with the rise of digital video and digital video transmission. And this is, to our eyes and in the systems that we have, one of the biggest gotchas that we deal with when we're troubleshooting with our customers is that we are often spending our time chasing our tails on an issue that may not actually be the correct issue because of this VCN thing. So I really wanted to make sure that got pointed out, that there is a difference with digital video between the EIA frequency that is being distributed and the actual VCN that is put out on the television. So how does this all affect us? What does this all mean, other than issues for troubleshooting TV systems, and other than the fact that we have prettier video now? What is this actually doing? Well, the cool part about it is with this 38.8 megabit per second bandwidth capability that we have in each one of these 6 megabit streams, we can distribute 4K. The technology is there with modern compression, and I think it's probably about a month ago, 2 months ago now, we did a full webinar on compression. If you have questions on compression, highly recommend you check out our video library and go back and look at that one. But with modern compression techniques, H.264, H.265, we can build 4K QAM channels at this point in time. So we can do 4K distribution on a QAM channel as a part of the CATV system in one of these 38.8 megabits per second 6 megahertz QAM frequency. So we can do 4K distribution now. I think I've actually seen a couple of our broadcast technology friends in the industry that are doing a program, or sometimes 2 programs of 4K in a single 6 megahertz QAM, which is cool. The system, the TV system itself, is actually taking up less space for the same amount of channels. So we went through this TV system transformation where when we started it was 2 through 13, and then 2 through 25, and then everybody's TVs went 2 through 68. I mean, and when we were at 2 through 68, you were actually taking up a full 6 megahertz wide channel for each and every one of those programs that was being displayed. So we were allocating 60 plus 6 megahertz channels on the distribution network for just these analog television signals. And then we went to the capper, right, where it was channels 2 through 134, and that was as big a gig. So it's really kind of still where we're at today. There are some higher frequencies being used, but that was about the maximum that you got on your analog system. Use channels 2 through 134, and that was frequencies 54 through 860 megahertz, with a couple of frequencies kind of popped out in the middle there for radio broadcast and ham radios and some other things. And that got you, again, 130 couple channels for 2 through 34, all analog, maybe 480 video quality. Today, we use far less of that spectrum for more and better programming. When we do installations in Manhattan, when we do installations in Sarasota, Florida, wherever we happen to be, that same 54 to 860 megahertz stream is open and available to the cable companies to provide content. Most of the time, they're stacking everything and using, maybe 30 channels in the middle of the spectrum, and then everything else around that is data. So this has been one of the side effects of this transmission or translation from analog to digital, is that we have gone from using up this wide array of the spectrum for video to using a smaller range of the spectrum for more and better video, and then leaving the rest of that open for data bandwidth. So those other unallocated frequencies that are no longer open or being utilized by the video system are now being used for data. This is how we get 1 gig pipe, 3 gig pipe, 5 gig pipe into buildings. It's many of those 38.8 megabits QAM frequencies bonded together, all being used for data transmission, so that you can have, as a corporate entity, this massive data pipe going into and out of your building, so that you can
talk to the cloud, the ever-present cloud. With regards to some of the other things that are going on, this is constantly changing. There's another bandwidth auction that is going to take place. I think it was announced late last year. I think it's like November or December of 2020. And again, what we're going to do is we're going to take a bunch of the space that the Fcc regulates, and we're going to auction it off, and eventually it's going to end up being cellular or satellite communications data, right? And there's really no way around this. If we're going to get to a world where we have everybody in the country with self-driving cars, this is going to require an absolute ton of communications back to 5G, 6G, whatever the next generation technology happens to be. Cell towers utilizing a lot of this RF space to send data communications back and forth in real time with minimal latency. So it's really kind of strange to look at it. It's one of the things that I always find interesting as I look at this world is what is happening to video, the move to digital, the desire to continually compress it so that it takes up less and less space is really a side effect of our continuing advancement in other technologies. It's because we want to get better with our cell data. We want to have more and more bandwidth available for cellular communications. We want to have more bandwidth available for communications to the internet, cloud storage, those types of things. All of this then has a knock-on effect of, okay, if we're going to do all those things, we need to be able to better compress video because we need to be able to put it into a smaller space so that we can allocate more bandwidth for data transmission and data communication. So how this affects us is really in our everyday, day-to-day lives. When we see a change in the video industry, we can look around and see a knock-on effect where there's also a change in cellular communications, there's a change in data communications, there's a bandwidth increase on what our service provider can offer us. The digital video world, the TV distribution world that we live in is very much tied to the rest of the industry around us. And that was kind of some of the stuff that we wanted to get into on the webinar today. I think I've taken up my normally allotted half an hour. I don't see any questions in my questions panel at this point in time, but if you guys want to send in some questions, I'm happy to hang out here for a minute or two and wait for them to roll in. If not, I will come back in a minute or so and sign off. All right, so we got a question from Steve came in. Is this presentation available? Yes, actually all of our presentations are available. Both the video form gets recorded, and you should get a link after this goes out. I'll double check with chat and make sure that that's the case. But all of these are available in our GoToMeeting library. And then if you just reach out to your account manager or to Chad Tully, we can get you the presentations as well. But we are kind of doing, as we're doing these things, trying to build a knowledge base for ourselves and our customers across the industry. So this presentation about frequencies and video transmission is really heavily tied to the compression technology webinar that we did previously. So there are several of these that would be worth your time if this one was good. So getting a couple other ones related to that from James. Is this webinar being recorded? Yes, it is, and you should get an email with access to the link in just a bit. And a question from Dan, can you talk about frequency or modulation relationships between OTA and cable TV systems? So this one's interesting. We run into this in a regular basis in a lot of our commercial installs. We have a lot of customers that what they are doing is actually bringing in, I'm going to tie this into a question I just got from Ernie as well. The discussed concept of QAM and what is it. So this is maybe something that we should do just as another webinar in and of itself, because it would take a little bit of time. But there's several different methods for transmitting video at this point in time, right? There is OTA, which is the basically what used to be NTSC, analog over-the-air transmission, and is now ATSC, and that's most of your local video content. So when I'm saying OTA over the air, what that actually is, it's a ATSC digital transmission that your local service providers are still required by law to provide as free-to-air content. So your local ABC, NBC, CBS, PBS, those stations have and are still legally required to provide that content in the clear for anyone who wants to put the antenna on their roof or antenna on their front porch, wherever they want to put it, and pull that content. So when we're talking about OTA, that is the discussion that we're having here. Those are the over-the-air local channels. Those over-the-air local channels, as you all know, tend to reside lower in the frequency spectrum. And the relationship here is pretty straightforward. The lower that we are in the frequency spectrum, I'm going to really generalize here, and my electrical engineer will yell at me later, but essentially the lower that we are in the frequency spectrum, the farther we can send that broadcast without needing to re-amplify it. So that's why you see ABC, CBS, NBC, your local channels in this low frequency range, channel 3, channel 5, channel 7. That is an ATSC broadcast. There are devices out there that if you're bringing this into a commercial application, stick an antenna on the roof. Blonder Tongue makes a really good one. And they will pull all of the OTA content within a mileage range, depending on the quality of that OTA content, and allow you to select the programs that you want, pull them off, and redistribute them as QAM. And QAM, to tie this into Ernie's question then, is quadrature amplitude modulation. And QAM is basically used by all of the cable TV companies for how they package and wrap their CATV and TV signal. And it's just a modulation scheme. It is the methodology for packaging the zeros and ones of digital video and describing those zeros and ones to the television in such a way that the TV can bring it back up. One of the hiccups that we run into, to tie it back into Dan's question, is there's two things to look out for. If you are injecting TV from your cable provider coming in as QAM and OTA coming from your antenna into the same television system, you will run into two issues. Number one, your frequencies can't overlap. If you are sending everything, you have RF channel 5 as an OTA channel coming in ATSC, and then you have RF channel 5 coming in from the cable company, and you mux those two together and try and send them out on the same video distribution system, you are going to get garbage when you try and display it on the TV. So that is one of the things to look out for, is make sure that those frequencies don't overlap. The reason that we prefer to put in an an OTA to QAM device when we are designing systems is because it does two things for us. It allows us to change those frequencies to make sure that we're not overlapping, and then it also allows us to get a consistent output of signal strength from that OTA to QAM device. If you have an antenna on the roof, the strength of the signal that you're getting is going to be dependent on the location of the nearest broadcast node for whatever that OTA channel is. So using an OTA to QAM device is always a good idea. It's going to even out your signal strength. It's going to allow you to remap the frequencies. And the other one that's kind of to look out for is that you need to be cognizant of the tuner in the TV itself. Not every tuner in every TV made available in the U.S. tunes both over-the-air ATSC and QAM at the same time. You can set them into a mode where they look for over-the-air channels, and then you can set them into a mode where they look for QAM channels, but there's not always where you can look for both at the same time, which can be problematic. So that is one of the other reasons that when we're designing systems, we prefer to just make everything QAM, is because then as long as it's got a QAM 64 or QAM 256 tuner in the TV, you run one scan, you're good, you get all of your content channels. So that is something that we run into on a regular basis with our systems. And that is probably a longer answer than what you were looking for, but between your question, Ernie's question, and then one of the other ones that also trickled in, felt like it was worthy of a long answer. Got one more from Robert. They're getting ready to deploy a Dish Smart Box and currently have an analog system with the Z-band and coax. Do they need to upgrade their Z-band system? And this is a great question. This is actually a really, really common one for us. No, you do not. So the Z-band system, and I'm just going to generalize even beyond that, even coax itself, is just pipes, right? They're just taking the 6 megahertz wide frequencies that you are putting out of the Dish Smart Box and sending them down copper. Single copper wire for coax, multiple copper wires, pin 7 and 8 for the Z-band system. They're not actually doing anything. There's no phase change. None of that's going on when we're looking at not messing with any of the encryption. None of that is happening in either a coax system or a Z-band system. The only thing to look out for is the frequencies that you are using. Specifically in your coax system, some of the older taps and splitters they have a megahertz rating for what they will actually handle in terms of traffic. So depending on how old that coax system is, you may need to upgrade some of your inline equipment to make sure that it's not knocking out higher frequencies. One of the cutoffs was normally right about 550 megahertz, which is channel 68 on that RF frequency spectrum. With the Z-band system specifically, if you have anything prior to 2008, Gen 2, you will probably want to look at upgrading, only because the Gen 2 systems, the baluns were passive essentially. They were a high-low switch versus the modern balun, which has amplification, sloping, attenuation built into it. So if you're using a broader range of frequencies, or if you push everything up into a higher frequency, those baluns are going to be a little bit more finicky. But that is something you can take up with your territory manager. Shouldn't need to make any upgrades on the forklift level, but may need to take a piece here and there, either of the coax system or of the Z-band system, and make some changes. Always recommend that you reach out to us before you do something like that, just so we're aware of what's going on and can be available for assistance on the day of that cutover. So please reach out to your territory manager so we can be sure to support you on that. I don't see any other questions that have come in, and I've given 2 ridiculously long answers to the questions that you have asked, so you're probably all very afraid to ask any more questions anyway. I'm got another one coming in. Got a question from Thomas. Are there FCC regulations for broadcasting over the air? Yes, there's FCC regulations for, actually you can look it up. There's published information. Anyone that wants to broadcast TV over the air has to register with the FCC, has to register city that they're going to be in, or the municipality that they're going to be in, the frequency that they're going to use, power, all kinds of other fun stuff. So if it's one of the first things that our engineers will check, if we're getting interference on a particular channel or two at a local system, we will go look it up with the FCC to see what the local broadcasts are in that particular municipality and look for frequency mismatches. But yes, the FCC regulates that because one of the really important things that is in that same 54 to 860 megahertz range is communications with airplanes. The FAA has a subset of information or of frequencies that it uses for communicating from the tower to planes that are in the air, and you're really not allowed to interfere in that space. So it is regulated by the FCC, just to make sure that none of the other technologies that are using that same 54 to 860 frequency space are being interfered with. Thank you. This is a good question, Thomas. Looks like that's it. I do have a couple requests for being able to share this. So we got another one coming in here. Cable virtual channels versus terrestrial. So actually interesting. Most of the time, the terrestrial OTA itself, right? They're not actually giving you a virtual channel. So if you have an antenna on the roof or an antenna on your front porch right now, you plug it into the TV, you do a channel scan, you get the two-part, channel 2.1, 2.2, 3.1, 3.3. I live in Hagerstown, Maryland, and the local broadcast company actually provides a couple of channels that way to the house if you have their cable TV packages. So you get the two-part VTC. Anything that you're pulling over the air, they don't tend to virtual channel map that. Everything is going to be in that 6 megahertz frequency that they're actually broadcasting in. So your local ABC station may be on channel 7. Everything's going to display 7.1, 7.2, 7.3. Cable virtual channels, and this is a really good point. If you have a cable set-top box in your house, if you have a business class QAM system, most of the time, again, in our experience with our corporate customers, you are going to get a map from the cable company, and we have several on file that we keep that is going to tell you, okay, this is CB, or this is CNN, this is the EIA table channel that it's on, this is its program identifier, so it's program 1 within that EIA channel, and then this is where we're actually going to display it on your TV, and it'll go through your entire channel map and give you that information. Again, that's our experience with cable companies. That information is available. They obviously have to have that on file for their own internal records. Residentially, speaking to residential customers, if you have a set-top box, all of that is VCN, right? Because you're flipping through. You don't actually have channel 515 to watch HBO. I mean, what frequency would that be in? We'd be up into the gigs for that. That is literally all VCN virtual channel mapping, and they tend to keep those. One of the things that happens with those, and one of the things to kind of be aware of, is not so much lately, but as we first did the digital transition is channels would just disappear because the cable company would redo their channel lineup and not necessarily push that information out to all of their customers. So we had several instances of Z-band having commercial applications where we're pushing through a feed from the cable company. Cable company makes changes to the actual QAM frequency where content is residing, doesn't tell the customer, TV disappears. So you now have either a different channel or a different program appearing on that same channel, or the channel just blanks out entirely. So to kind of pull that back to the question, with over-the-air content, ATSC, you don't tend to have a lot of virtual channels in the raw transmission. with your cable TV companies, specifically in that residential environment, everything is a VCN. I mean, you have no idea, unless you're going to take an RF meter to your cable TV box, what actual channels are being used for the programs, because they VCN everything at the residential level, and then even a decent amount on the corporate level, depending on who your service provider is. Appreciate you guys sticking around. We still have 40 of you hanging out on the line right now. I do not have any additional questions at this point. I will hang out for another minute and then probably sign off. I really appreciate the interest. This is far and away the most questions I've gotten on one of these, and definitely the longest that anyone's listened to me yammer on so far. So greatly appreciate it. Thank you very much. All right, no other questions coming in. People are starting to sign off by the tens now. Be on the lookout for an email. Will contain a link to this webinar. You can feel free to share it with anyone you want to share it with. They will have to provide us with an email address to access the GoToMeeting panel. But that's basically it. Again, thank you guys very much. Have a wonderful day.